So we'll look at some lenses here. First up is a convex, skinny on the edges, a little bit fatter in the middle. This one's not particularly fat, but you could feel it with your fingers. And then as you hold it near your eye, right side up or upside down? Magnified or not? And then as you move it further away, look what happens. Right side up or upside down? Magnified or minified? Here's the second one, a little bit fatter. Right side up, upside down. Magnified or minified? If I pull it close in, it just won't focus. Here's the third one. Also convex. This one's similar, not identical to the first one. And this one is a concave, which means it's fat on the edges, skinny in the middle. And no matter how far away I hold it, or how close I hold it, the orientation of the image stays the same. Is it minifying or magnifying? Okay, we have a pretty simple setup here. I'm just sitting in the doorway of a room. There's a window to my left where the light's coming in. The lights are off. It's certainly not particularly dim or bright in here. You don't want it super bright, and you'll see why in a minute. So you can see an image coming up on this door. The door is just going to be my little white screen. And the meter, this is a measuring tape, but it's got centimeters, which is great. A lot of lenses are measured, their focal length is measured in centimeters, and we certainly want to do that too. You could use a meter stick, that would work fine. So we're just going to play around and move it back and forth until we see a clear image on the screen. There it is. And that's happening right at 20 centimeters. Wish you could see. You need to do this in person because it's so much brighter and cooler to do it yourself. I'm just here showing you kind of what can be done, how to do it. This one is 15. Here's another one. This feels a lot flatter. That one's about 40. You see that? This one is 10. You probably figured out that the closer they are, the brighter they are. They're collecting all that same light and focusing it, but the image is smaller too. It's a really tiny one. I don't know if you can tell, that's about 5 centimeters. I don't know if you can tell by looking in the screen here that the image, can you see if it's upside down or right side up? It is upside down. And this is a concave lens, which means it's fatter on the edges than in the middle. It is a diverging lens, which is why things look smaller. If you are nearsighted like I am, these are the kinds of lenses you need to correct your vision. But if you try to do it with this kind of lens, if you borrow somebody's glasses, it will not make an image. In fact, it makes a shadow, because as the light goes through it, it diverges, it spreads out. It doesn't converge or focus. So kind of cool.